to mention, guys, in this week, you are free to choose any other process or an adaptation or modification of the techniques that we already been doing, but in a way that they're still done digitally. So you should have still to design something in the computer, and then you have to throw this design into a machine, and the machine should produce it. If it is maybe non-planar 3D printing, that could also be accepted, for example, food printing or metal bending or whatever, then this is the specific technique. So don't just, make some bioplastic just by mixing the things and then, okay, this is the assignment. There should be some, digital process involved. Even with the, I don't know, hot wire foam cutter, for example, needs to be digital. Yeah. Yeah, I think from my side, I didn't prepare anything so well as Ferdi, but I have a couple of things that I can show to you. So the first examples that I can show to you are about food printing. I don't know, guys, if you can see my screen.
You're gonna make me hungry.
It's good. It's good.
Yeah. So some time ago there was a lot of pushing to 3D print some food. In this case, with food we mean some kind of pasty foods, so like this creamy or semi-fluid food. And we did some experimentations. Like this woman here was printed in marzipan. We did also some printing in chocolate, like in 2D here, or 2.5D, or almost 3D. We also tried to print different materials. So this one was marzipan, that is almond oil and so on. We also tried to print meshed meat here. We also printed some creamy cheese over here. And we also tried to print just the outline of the things. We experimented a lot. This was made by Mark. What he did, because the printing area was rather small, he printed like in subsections, like 1/4 of this shape of this image over here on 9 of these biscuits, just to make the overall tree. We also tried to cook afterwards the food. And yeah, although the machine is not 100% certified with food production, we cleaned everything and we tried it. And yeah, of course, the taste doesn't change because it's just the shape that is different in this case. Yeah, here some nice comparison between 3D printed parts and 3D printed parts with marzipan. And the things that you can realize are, for example, that the overhang angle are really limited. So you can see here the beard of the horse that was not in the original model, of course. And you can see that some of this town or this like queen and so on, they are like having an inclination, like the Pisa Tower, because the material is so fluffy that it bends very easily. And yeah, we also make some kind of weird creams, like with chocolate and milk and so on. I think you can experiment a lot with this. So I also made a guide if you guys would like to print with food. That is already shared in our wiki. In this case, is about how to print with marzipan. So we have 2 machines in the Fab Lab that you could use to print with food. One machine is the chalk creator. It's rather a small machine that can print something about like 10 by 10 by 10. And it's made on purpose to work with chocolate. The other machine that we have is from Netherlands. It's called Lutum. And it's this printer over here. I think you have seen this upstairs. It's made for clay, but it works very well also with marzipan. And both machines, they work through a principle of having like a cartridge filled in with material. and then they push these cartridges with different means. So in the one that we have for clay here, what you could do is you could like pre-prepare some marzipan. You have to make it the same shape as the cartridge. So here's the cartridge, it's like a cylinder. And then in this case, you have to roll it like a cylinder. And then you have to fill this inside the cartridge. It's really crucial and important that inside the cartridge, you are not going to have any air bubble, because then this results in no flow during a certain amount of layers or curves and so on. And then you lose, let's say, some layers of your print. So you print then in the air. And then the way that this machine pushes the cartridge is by using air pressure. So there is this cup over here, and then once you close the cartridge, there is a hose with a small tube that you can connect, and then there is a compressor that you can regulate the pressure, and this will push in the material over here. So once you are, of course, you need to extrude a little bit to make sure that the initial air bubbles are gone and you have a constant flow of material. So once you have your cartridge set, we also prepared some settings for the slicer. So in this case, the slicer that can be used is slicer written with the 3 instead of the E in the name. And it's an open source slicing software for which we developed together with the company this bundle configuration. So in this bundle configuration, you're going to have all the proper settings to print with food. So here you can see the all settings in case you want to replicate your work. And then what you can realize from the software itself is that, of course, food printing, in this case with the pastel material, is not much different than 3D printing, but just the layers, of course, are really big. So they're really fatty and big. So like this one that you can see over here. So here the layer height, for example, is 1.25 millimeters in comparison to, of course, 0.2, 0.15 from normal PLA printing. Therefore, you're going to have really rough shapes. You're not going to have really precise surface finish over here. So many of the details will be lost unless you print something that is really huge and big. So food printing, guys, seems easy, and I'm telling you, it can be rather easy for some small pieces, which they might have, let's say, really few amount of details. But for big pieces that have more details, it's going to be rather difficult. Some limitations, apart from the hovering angle of the prints and the fluffiness of the material, so that it's not really good for structures, is given by the fact that the properties of the material are changing according to a lot of parameters. Not only, of course, I don't know, like the rotational speed of the stepper motor to extrude the material, but also, for example, the temperature, the humidity, the pressure that you apply to push it. So according if the material is Newtonian or non-Newtonian fluid, okay, of course, can change the viscosity according to the pressure. So this means basically, guys, that to print this woman here, you need to stay all the time close to the printer, and you need to constantly check that the flow is correct, is the amount that you want, and you increase or decrease the pressure accordingly. So in for example, Christian from 2018, I think your colleague William, did some experimentation with marzipan and this other small machine that we also have. This other machine is the, let me look in the wiki. It's a very small machine, a portable machine that can print just a small syringe of material. Let me see, Ferdi, if you have added it. So here's the chalk creator, the Lutum.
How come I posted Daniela, but I don't remember how it's called.
It's the 3D by flow. Now remember.
3D by flow, exactly.
Yeah, 3D by flow.
Upgraded it. He added a fan to it also to cool down the chocolate.
Yeah, so this works, as Ahmed said, similarly to the Lutum, where you have this compressor with a hole, with a tube, so here, pushing the material through here. The difference is that this has a very limited space for the material. So there is only this small syringe, which is just a few cc's of material. Therefore, you can just print really small objects. So this one, that is the example from Christian Plugari. And in his case, he had some issues because he didn't put enough material inside. And the other issue was that he was adjusting the speed. So at the beginning, he was going really slow, like, for example, with a speed of 10, to make sure that the pressure that was applied by the machine here had the time to propagate here and to extrude the material properly. And then once the flow, it's constant, so there is a constant pressure all over here, he adjusted the speed to 200%, so to the maximum. And this just to have a constant flow. So 3D printing food, it's more like using your intuition, especially for the flow. You need to stay there and to check it constantly. Yeah, and this was the small example from Christian. Another limitation that you might have is that when you have jumps, so let's say that you print 2 of these pancakes, one on the side of each other. Every time that you have jumps, the retraction is not working very well as in the normal 3D printers, because in this case, even though you retract a little bit this syringe, this piston over here, there will still be some pressure over here, leaving some wires or some, let's say, extra parts, like these ones here on the top. So therefore, for many of these examples, there is going to be a huge post-processing in cleaning the parts, like manually. So you have to go there with a pincetter tweezers. I usually use those. And then you have to remove all the small parts. So 3D printing food can be rather fun. If
the bonus is there's no waste, right? So you just eat whatever's left over, right?
You can push it through the one that is left in the cartridge, of course, with the pressure. But the problem is that on the syringe or on the lead screw, that this, let's say, the mechanism that is inside this from Lutum. Here, maybe you can see a video about it. There is going to be a lot of small pieces left over there, so you need to clean that one. And unfortunately, that one, it's always a little bit of a waste. And this is one of the reasons why Gaia doesn't like very much these machines that we have in the Fab Lab. She's designing another one that could overcome these issues of wasting material. Yeah, so what else I can tell you about food printing? So of course, to print 3D chocolate, you need to make sure that the chocolate, after is being extruded, it becomes instantly solid. So for doing that, you need to make the temperation of the chocolate beforehand. And the problem with the Choc Creator is the small machine for chocolate that we use to make these shapes over here, is that you need to have a super stable temperature inside the syringe, because if you mess up with that temperature, then you can basically throw away the chocolate, or just, let's say, eat it, not use it anymore for.
Then you have to eat it, yeah.
Yeah, you have to eat it, not to. So we were trying a lot with Nutella, and Nutella was, let's say, working very fine for a few layers. But then once we extruded the Nutella, we tried to put back the Nutella. The shear stress, the compression that the Nutella had after the first extrusion changed its properties, and then was not good to be printed. Even though, for example, you warm up the Nutella, for example, and then to make it more fluid to be printed and so on, this changes completely the properties.
Well, yeah, because that's how you make fudge.
Guys,
sugar and chocolate they're both very. I think it's mostly the sugar that complicates it, but it changes a lot with different temperatures, and sometimes it crystallizes, sometimes it doesn't. So tempering
That-
chocolate is not a science, but an art.
But trying to 3D print in cheese would be the same problem.
I think, Gaia made a sort of like a mixture that was really stable to be printed with the 3D by Flow. I will try to look for the recipes and tell you. I think it was some kind of sugar and water and some kind of gelatin. Maybe fairly similar to the gelatin that you gave me or you showed me the last time.
Yeah,
So there
is nice and easy to print.
Yeah, so guys, there is a lot of experimentation that you could do with food printing, and in these files, that is this document that is already shared in the wiki, you can also find all the configuration files for Slicer. So this software, so you can download these files over here, and then here is Slicer. You can do just file, load config from here. Open the configuration file, and then this is totally like Cura. So you can just add, and you can just open your files and add three-dimensional parts to it and so on.
Cool.
So guys, if you want to try with this, will be rather fun.
Kai was just asking about printing with clay. Have you tried printing with clay?
We have tried printing with clay with a big wasp with the Delta 4070 that we have, and I think we even changed the nozzle and adjust the height for clay, and I think we
Probably
made like
still set up, isn't
a
it?
base. Yeah, I think it's still set up. So if you want to try to print with clay, I think you can just try again. I think the last time we managed to have a print, like a small vase. And we also have plenty of clay. I mean, Mark has a giant pallet of clay. We also mix the clay with alcohol and water, if I'm not wrong. Yeah, I think it could be good to test it if you want. So clay should be more stable than food, but still will be like, as fairly said, also kind of a hard in changing the pressure and so on.
Have you made any experiences with the oven, with the ceramic oven?
Unfortunately not, but I think we have really an expert in the public, which is Mark.
Yeah.
Because Mark has done a lot of experimentation with clay and from artistic perspective. And we also have a oven in the Fab Lab. Could fire the clay. It's in the technical. So guys, if you would like to try with him, would be good.
How about Mark anyway? I mean, is he recovering? Did he have any surgery? How's that going?
He was here today. He won't have any surgery if everything continues like this. And yeah, like I think he's also looking forward to coming back.
Oh, that's good.
Good to hear that.